record on this computer.
Okay. Okay. Hey friends, I know y'all sad I couldn't be here to give you these notes, so good thing I'm here giving them to you on Zoom. Okay, so for my warm up, we've seen this already. So it says a cube has a side length of s equals 2x minus 1. Find the volume of the cube if b equals s cubed. So I know my s, it gave me the formula, all I gotta do is plug it in, right? So it's saying, hey, b is equal to 2x minus 1 times 2x minus 1 times 2x minus 1. A bunch of different times. So what I can do is my box method, I gotta do it 2 times. So I'm gonna do box method for one of them. Got a 2 by 2 because I have 2 terms in each. It doesn't matter where they're placed because they're the same thing. So I'm gonna say 2x minus 1, 2x minus 1. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Same thing over here is negative 2x. And negative 1 times negative 1 is 1. Gotta combine my like terms. So I say negative 2x and negative 2x are the same. I'm gonna go over the side and say what's negative 2x plus negative 2x. Gotta drop my common term, so my common term is x. Negative 2 plus negative 2 is negative 4. I got all I need for that one, so I can set up my equation with my highest term first. So I say 4x squared minus 4x plus 1. Now, that marks off this one and this one, leaving me with my last term. So I still gotta multiply those two. So I'm gonna say 4x squared minus 4x plus 1 times my 2x minus 1. Gotta figure out how many boxes I need. I know this one has 3 terms and this one has 2. So in total I need 6 boxes. I need 2 down, 3 across. Our terms do matter. The 3 terms have to go up in the 3 windows. Okay, I'm gonna do 4x squared times 2x. I get 8x cubed. 4x squared times negative 1 is negative 4x squared. This box right here, I need to multiply negative 4x times negative 2, or sorry, just kidding. Negative 4x times 2x, and that gets me negative 8x squared. My bottom box, I do negative 4x times negative 1, getting 4x. Up in the top one, I got 2x times 2, which leaves me with 2x. My bottom one, negative 1 times 1, is negative 1. Cool. So now I gotta combine my like terms. My x squares are the same, and my x's are the same. So I gotta go and add them over in the corner. I'm gonna say, hey, what is negative 8x squared plus negative 4x squared? Since I'm adding, I can drop my common terms of x squared. And negative 8 plus negative 4 is negative 12. And then my next one I have 2 plus 4, or sorry, 2x plus 4x gets me 6x. Now I can write my equation with the highest term first, which would be in my upper left-hand box. So I have 8x cubed minus 12x squared plus 6x minus 1. Cool. Okay, Today, we're basically going to be doing the same thing. We're still going to be finding our volume. We got base and heights, or we'll be doing like length times width or height, whatever we have. We just need to go and find our equations and plug them back in. So my example today says propane space heaters are a versatile solution for heating a variety of rooms, including garages and workshops. A table from the manufacturer's catalog shows specifications for determining the right size heater by various sizes of space to be heated. So my first question is, hey, what type of function is b of x? We could go two ways. My first way being, hey, look at this equation and see I have an x squared plus 24x plus 140. Right. Ooh, backtrack. Actually, let's fill in my missing table. So let's look and see what we're doing. It's telling me to multiply my bx times my hx. So I take my b column, multiply it by my h column. So I'm going to do 140 times 6. 140 times 6 is 840. So 165 times 7 is 1155. 192 times 8 is 153. 1536. Sorry. 221 times 9 is 1989. And my last one, 252 times 10 is 252, or 2520, sorry. Cool. Okay. So for my first one, it's saying, hey, what type of function is b of x? Now we could flip back from what we did on 8.2 when we had to like determine, oh, my linear versus my quadratic functions. I know that linears are my ax plus b, and my quadratics have anything that's raised to a 2. So like an ax squared plus a bx plus c. So I could look and see like, hey, what's the highest degree that I go up to here? The highest one I go up to is a 2. So I would be quadratic. Or if I'm not chill with that, that's cool. Because on your assignment today, you're also going to have to do differences because I don't give you an equation. So you have to determine it yourself. We can go and do differences with just that one b of x, right? So I would start from the bottom and subtract up. I could do 252 minus 221, get me 31. 221 minus 192, giving me 29. 192 minus 165, giving me 27. And my last one, 165 minus 140, giving me 25. Okay, so I know round 1 wasn't constant, so I gotta go round 2. Round 2, I could start from the bottom, subtract up, and notice that I get 2 all the way up. Cool, hey, that makes me quadratic. Right? Okay, my next one is saying, hey, what type of function is h of x? I could look and see h of x has an x plus a 6. I could flip back to 8.2 and say, I got an x with it as my highest degree, and I know that's my linear. So I could say, hey, that's linear just by looking at the equation. Or if we're not chill with that, that's cool, that's fine. Go and do your differences for just h. So I would start from the bottom, subtract up, and the whole way up I get 1. Making me, hey, my first round was all constant. Since my first round's constant, I'm linear. My My next one will be v of x. So v of x, I need to figure out what type of function it is. So gonna work with just those finite differences starting from the bottom, subtracting up. Gotta go round 1, round 2, maybe even round 3. So first round from the bottom up, I get 531, 453, 381, and 315. So based on my first round, I know, ooh, those numbers aren't constant, so it's not linear. I gotta go round 2. Can go round 2, starting from the bottom, subtracting up, 78, 72, and 66. Second round wasn't constant, no biggie, gotta go round 3. Round 3 from the bottom up, I get 6 all the way. So third round constant makes me cubic. So you could do that, or you could also look and see, hey, I had a linear times a quadratic. I know a linear function times a quadratic function is going to give me cubic. So my first question is that, or number 4 now, is going to ask me to use finite differences to write a function rule v of x, then check my answers in the calculator, blah, blah, blah. Okay. So when I'm writing finite differences to do my function rule, I want us to use, so finite rules slash regression. Okay, so I know I went and did all my regression for v of x, which is fun. So I know I'm cubic, and I know for cubic that you're gonna have my poster in my room. It's gonna say what your linear, quadratic, and cubic regression is. And I know I'm wanting v of x is cubic. So I'm going to use cubic regression. Is y1 squiggly ax1 cubed plus bx1 squared plus cx1 plus d. Okay, so it's asking only for my v. Before I can go and type in this regression, I have to go and make my table in Desmos. So I'm going to use my x column and my v column. Oh, where did it? So I'm going to go make a table. These. Add table, create it. I go 0, 1, 2, 3, 4. Okay, and then my V column, I have 840, 1,155, 1,535, 1,989, and 2,520. So I knew I was cubic, so I can go and run my cubic regression of y1 squiggly ax1 cubed plus bx1 squared plus cx1 plus d. Now, Desmos is so kind, Desmos is so sweet. Desmos will tell me, hey, what's my A, what's my B? B40. Oopsies, haha, I messed up on one of our numbers. This one in our table should be a 6. My apologies, sincerely. Okay, so I have my A, I have my B, I have my C. We should probably go back and change that in my table too, so we don't get messed up. So I'm gonna say, hey, what is my A equal, my B equal, my C, and my D. My A equaled 1, B 30, C 284, and D 840. Go back. Okay, remember I said I was gonna change this to third to the 6. Okay, so I have enough information to write my cubic formula. Cubics looks like y equals ax cubed plus bx squared plus cx plus d. So I have my a, I have my b, I have my c, I have my d. All I do is just go plug it in. So I'm gonna say y equals 1x cubed plus 30x squared plus 284x plus 840. Oh, I gotta go and shove that in there. Okay. My last one we're gonna do is write a function multiplying. So we're gonna use the box method for this one because it's asking me to multiply b times h. So again, just so I know how to use both of the methods, we're gonna do both. So my b is my x squared plus 24x plus 140. And my h of x is my x plus 6. Now, box method tells me, hey, I need to determine how many boxes I need. How many terms I have of 1, 2, 3. So I have 3 terms by 2 terms. So in total, I'm going to need 6 boxes. So I'm going to go over here and draw my 6 boxes. Okay, remember, it does matter where we go and place our terms in our windows. Only my x plus 6 can go on my 2 side, and my x squared plus 24, ooh, that was bad, 24x plus 140 can go on my windows. So, gotta go and multiply. I need to say, hey, what's x times x? Well, first of all, what number do these x's get? A 1. So, I need to do 1x times 1x squared, gets me 1x cubed. Then I have 1x squared times 6, gets me 6x squared. Over here I have 1 times 24x, or 1x times 24x, getting me 24x squared. Down here I have 6 times 24x, getting me 144x. Up top, 140 times x is 144x. Oh, lies, 140, sorry. 140x. And my bottom one, 140 times 6 is 840. Okay, combining like terms, I'm gonna go and say my matching ones are my x squares and my x's. So I'm gonna come over to the side and say what's 24x squared plus 6x squared. Draw my common terms. My common terms are my x squares. 24 plus 6 is 30. Then I'm gonna hop over to the side and say, hey, I also need to do, oops, sorry, my hand. 140x plus 144x. Dropping my common term of x. My 140 plus 144 is 184. Or lies, sorry, 284. Okay, so I've done step 1, 2, and 3 based on my box method steps. My last step is, or actually I did step 4 too, but now I need to set up my equation. So starting from my highest term, working backwards to my lowest. I have 1x cubed plus 30x squared plus 284x plus 840. Now, crazy enough, it matches the one that I went and did when I went and did, or matches the same function as when I ran my regression. So the other day, I know I was telling you, like, they go hand in hand, one's easier and one gets things done a little bit faster. But on your assignment today, it's one big question like this one, but unfortunately I don't give you these equations, so yes, you do need to go and run your differences for your length, your width, your height, because that's your example in your assignment. So have fun, make smart choices. Easy.